So Richard is one of the co-founders of the xxDK network and has been working on the development for this since the start. He's also the chief cryptographer and has been doing this work for a very long time. If you look into and peep into his previous experiences on LinkedIn, you'll find that he's worked as a software engineer in the late 90s for one of the government services. And the reason why we have got this xxDK network is because there are a lot of people who are looking forward to promote privacy. We are looking forward to getting online. And when we get online, we need a lot of tools that help us in keeping our identity, our online identity private. That is one of the most important things that we do. So xxDK network has got some amazing technology. The xxDK network ecosystem has been founded by Dr. David Shom. I'm sure Rick would tell more about him in the session. It's just that we are very excited. This is the first event that we are sponsoring officially in India. And we would really love to introduce the developers here to xxDK network and its technology. India being one of the biggest producers of software and technologies could contribute a lot in what we are trying to achieve. So without talking more, I would hand over the presentation to my colleague, Rick. Over to you, Rick.
Thank you so much for the kind introduction. And this session is going to be more coding than history lesson, but we'll start out with that. As you said, I've been working with David Shom since I graduated college. I met him when I was at a presentation my senior year, where he was talking about a voting system, and he made this comment. He said, I haven't found anyone who knows how to build this yet. And it became very apparent to me that it was very obvious how to do it. And I think about 6 months later, we were demoing it for people. So it's been a long journey. I think it'll be 20 years next year. So we've been doing this a long time. Without further ado, let's get into it. So we're going to cover the xxDK Networks developer kit. There are a couple of public examples that you can go and use. These links here on the right, proxy.xx.network. You can go to alpha.speakeasy.tech, and you can go to echoxx.tech. This is a brand new system that uses the Ethereum public-private key to create an identity on the xxDK network and allows you to send payments to others and be sure that the person you're sending to is that person. And if you want to learn more generally from a developer perspective, right now the best place to go is wiki.xx.network. So a little bit of history before we get started. Back when the internet was first developed, right, they decided how your digital life would work. And that happened in the early 80s, before I think most of us on the call were born. And David produced this MixNet proposal. And the idea behind that was, how do we ensure that what we have in the present day in the 80s, where if you talk to someone one-on-one, that conversation is private, can you provide that level of security when you go onto the internet? And that is how your digital life should work. And since then, they've only taken that first path, largely for optimization reasons, right? It's faster, right? But we are finally getting around to, can we, 40 years later, can we make this work? And can we provide an option for people to really have high security, high metadata protected environments so that you can go and operate online and not become a target for malicious actors, malware, bad guys? Let's talk a little bit about what a MixNet is and why you would use it. So the basic system is you pass your message to a node, and then multiple nodes mix that message. And generally speaking, what they do is they are adding encryption and then removing a little bit of encryption at each hop. And what that allows you to do is, under the set of all messages sent, be sure that the sender and the receiver are unlinkable, so that you don't know who necessarily sent the message to the recipient, and the recipient has no linkage back to the sender per se, unless that linkage is included in the message that was sent. It was introduced, like I said, back in the 80s. And it was, at the time, impossible to build these systems because we did not have the computational power. And that's changed recently in two major ways. One is we created, David and a bunch of colleagues, my former advisor, Alan Sherman, and I can't remember the other names, but they realized that you could pre-compute the message computation, the public key part of the messaging. And they published that paper about 8 years ago in 2016, 2017. And the second thing is that we now have these GPUs, they're doing AI. They also happen to be very good for these types of public key operations at scale. So when you have that pre-computation step, you can reduce the real-time latency down to a very small amount. And we have real-time latency in the network on the order of under a second at this time. And what that means is we can produce and push significant amounts of data through the network, not direct connection level amounts of data, but it's competitive with a lot of messaging platforms out there today. So the messages will appear. You can bring up iMessage or Telegram or something like that, and you're comparable with the delay on systems like that. And that's kind of how we built our platform. So we take advantage of this pre-computation step, the P here in the diagram on the bottom right, and then the real time, and we line up a bunch of real-time operations so that you can get a continuous flow of real-time sends and real-time receives. And the delay on that is definitely on the order of about a second. And if you break that down, there's 5 nodes in a team, and there is roughly 50 to 150 millisecond delay between the nodes, and you're going to pass through those nodes. So add that up, you're well within a second to 1.5 seconds if one of the nodes is slow. And why would you use this? You use it for messaging applications. You're not necessarily going to post video or audio through it, but you are going to, establish a link and establish sort of an anonymous key so that you can use a separate server to send and receive audio and video. There's all kinds of possibilities. The big one for me has always been election systems. You literally can't have a secure election system without a platform like this. And it's very exciting. We've now got 370 nodes that are active, and the system's been running continuously since 2021 in November. So that's enough of the high level academic discussion. Let's talk about how you use it. And all the examples I'm going to show you today are at this Git address. It's git.xx.network, xx_network, xxDK examples. You can download them, you can run them. They've got readmes that explain how to run them and how they were built, so that you can go and build applications with this technology and using this technology. So like I said in the beginning, we've got JavaScript, we've got iOS, we've got Android support. The main clients are on the left here on the bottom side under the brand name Elixir. That is the US-based entity that built a lot of the MixNet client software. And on the right, you've got Speakeasy, which is a public open source application. You can download that and compile it. There's an example Android client and an iOS client if you're interested as well. And those are full-featured applications. Let's dig in a little bit and give you a very simple JavaScript example. That example is the React.js folder inside of the xxDK examples repository. The first thing you're going to have to do is download Node.js. I hope everyone on this call knows how to do that. But if you don't, you go to nodejs.org/language/download, and it will present you 2 or 3 installers depending on your operating system. Once you install it, you can open up the terminal window. You can type the node-v, get the version, npm-v. These are the versions we're using for the example. Once you've done that, you can create a brand new app, npx create next app at latest. I literally use the defaults here, and that will create a basic React app. Once you've got that, to use the xxDK, you install a package called xxdk-wasm. I'll give people a minute to digest that. If you go and look at the example, you'll see that this is the main page. And I'm going to show you a video of this at the end. So it's what you see here is literally what I'm going to be showing you. And you'll see that you have an XX network directive and you have a XX direct messages directive. We are using the XX direct messages submodule of XX network for this demo example. We have a box for receiving messages and a widget for displaying those received messages and returning them. And then we have a box for sending those messages, and that displays like a little text box for you to type, and then a send button for you to send. And the important things to note here are that these directives here, these tags, they both have context that you need to build out your application. So let's look at the first one, XX network. So XX network is, there's 2 contexts that it uses. One is, one of those is we're calling it xxDK utils. This is, it's all built on top of something called WASM, which is WebAssembly. And this is your link into the functions that are exposed under WebAssembly. And this cMixx one, the nodes that do the message processing, we call that protocol the cMixx protocol. And that is essentially, you treat that like a network connection. So I call it xxnet in many of the examples. So we're just going to create a standard React system where you have children that are passed in that are just plain vanilla React nodes. And then we're going to set up state variables that this context provider is going to use in order to set and update those state variables. And they're going to get linked up to the XX context and xxnet variables. So when you get into your use effect function, which is over here on the right-hand side, you'll see that we have to tell it where to find the WASM variables. What we do in the example is we locally host them, and you can do that just by linking the xxDK WASM. And we also have an S3 bucket where this stuff is hosted by default, so you can go and just use the default S3 bucket, and that'll work fine for you as well. And it'll be downloading from our CDN. But I think the preference here is probably to host it locally because it'll be a bit faster, because you won't have to download a 30 megabyte binary blob. Once you've got that path set, you can initialize the XX network. This will set that context variable, the local state variable, which will get linked to that context variable, and then it will go and initialize the network. And at the end of that, let's walk through that. So we have, in order to connect to XX network, you need what's called a network definition file. We have that network definition file just inside of the app. It's called ndf.json, so it just loads it. And the next variable is a state path variable. So this is a prefix added to local storage. Generally speaking, you can leave this empty. I tend to put some small prefix. If you put too big of a prefix, you can get past the key state size. So generally don't make it more than 4 characters long. The secret is the password used to encrypt all the data in the state. It's your identity and the secrets used to connect to the network those are generated randomly. You can export and store those. That's part of the API. That's something that you're gonna have to go look for if you want to learn how to use it. But the actual data that's stored on the browser is just stored with just sort of a separate password, which is what this is. So it's not a seed phrase or anything like that. It's just an encryption password. For now, we just use the dummy string hello. The params is an option. In general, I recommend that you use the default parameters. You can do that just by using empty string. And all of the data that we use tends to be byte arrays. And to generate those byte arrays, you're going to be seeing a lot of buffer.rom. You're also going to be seeing buffer.from parsing base64 and creating base64, so on and so forth. Once you have that, you also need a variable to check to see if you've initialized cMixx already. You initialize it with a new call, then you mark that you've done it if it returns and doesn't crash. Once you've done that, you can load cMixx, and then you can set the state variable. So the two state variables are at the top here: set xxDK utils and set xxCMixx. Once you've got those state variables, you can link them up on the left-hand side here. That xx context provider is set to the xxDK utils, and that xx net provider is set to xxCMixx. You can see xxDK utilities and xxCMixx. That is the xx network provider. Let's look at direct messaging. Direct messaging has, it uses the context variables from the provider. It also creates two more state variables that it provides as context, and it creates a reference variable for a database lookup. And by default, when you're on the Web3 version, it forces you to use IndexedDB because it's the only option. And that's what that DMDB is using. Dexy is just a common library. You don't need to use Dexy, but I recommend it. It's the same idea. You've got context variables at the top, the receiver and the client. The receiver receives the messages, the client provides some state and it lets you send messages. And you're going to do the same pattern as before, where we verify that the context is passed down is not null. And you need this guard at the top. And you also need, I'm going to skip ahead to the bottom of the useEffect function, but you also need, you also need the xx and xxnet listed on the list down below, because they are going to update. They're first going to be set to null. This useEffect function will run. It will hit that first guard at the top here, and it will return. To get the useEffect function to run when those variables are set, you need to mark them as being listened to in this useEffect function for the direct message receiver. Once we've done that, we're going to create a random identity if one's not set. Then we're going to export that we did it, and then we're going to store it. The notifications is not an option inside of the web, so just a dummy variable there. But this database cipher is required, and this is a separate encryption password for entries in the database. So the actual text of the messages is encrypted in that database. We also define a reception handler or callback function. That's what onDM event is. And you'll see that this onDM event is literally going to take in an event type and a data, which is a JSON byte array. And it's going to parse that data, and then it's going to do this database lookup on the right-hand side. This promise.all is calling two functions. The first one is a lookup on the message ID, which is that e.uuid. And the second one is a lookup on the conversation, which will have information like the user's nickname and things like that. If it finds those things, if it doesn't find those things, it prints an error. If it does find those things, it'll print a little message and then add that to the DM receiver listener. So that's what set DM receiver is doing. So that's what the callback function does. The rest of the use state finishes initializing the client. So it's going to grab the DM index DB worker path is a web worker. Again, that's something you're gonna have to look up. That's kind of outside the scope here. It will essentially initialize a separate thread inside of the web app that will handle database reads and writes for you. And then it will initialize the client once that web worker is initialized. Or sorry, once that web worker path is known, it will then initialize the client. That client will start the web worker. We're printing out the direct message ID, and we're printing out the direct message token. So a token is just a number, it's a random number, and it acts as an additional password. So you can have apps that broadcast a public ID, a public key in many contexts, and then you can sort of disable direct messages by just not listening on that token. And it's a very nifty little feature that enables you to have kind of different groups of direct messages that you can control, and it protects your identity on the system in general. It protects your inbox, not your identity. This database, we use a really basic name, which is the public key without when you do base64 in general, it adds these equal signs at the end to make it a multiple of 4. And it uses raw encoding, so it drops those equal signs and then adds a postfix of _speakeasy_DM. And that sets up the database. And once you've set up that database, you are good to go. And this dm.db.current is actually setting the reference for the database. And then we start the networking, and then we check to see if the direct messaging client, or sorry, we don't check, we set the direct messaging client to the result. Once that set DM client is set, then all the context becomes available to the people listening, or the objects listening under the DOM. And you can see on the right-hand side, you've got xxDM client provider and xxDM receiver provider. And they're just set to that DM client and DM receiver. That's set at the beginning. So at this point, all of the context is loaded. Let's look at how messages get received. It's super simple. We're looking at the context for the DM receiver, which is calling that callback and sending us messages. If we don't have any messages, we just print nothing yet. If we do have messages, we print them. And if you've ever done React programming, this looks incredibly familiar to you. And let's look at message sending. So message sending is slightly more complicated because it needs to look at the direct message object and actually send that message. So we've got handlers for when you're typing. That's what handle input change is doing. And we've got a handler for actually submitting the message. And what that does is just clear the message after calling the DM send function. And that DM send function is pretty simple. We're just going to send to ourselves. So we get the current token and the current public key, and we send whatever was in the text field to ourselves. And you've got on change and on click. These are pretty standard events inside of React. Right. So that's not the only example. There's an Android example. There's an iOS example. And then there's Golang is what the app is written in. So there's also a Golang example. And if you need it, I have a C# example too. But it's not in this app. It's not in this repository just yet. Let's take a look at some demos. This is the Android example running. Full screen that for people. And on the top here is just the console log for XX Network, the library once you load it. And what you'll see in the bottom is this received messages window. And what this is doing is it's processing events. You can have up to 3 events. So if you're sending a message, the first event is the message being sent and accepted by the network. The second event is the message being processed by the network, which means you got an alert that the so-called round is done. And then once the round is done, your client can go pick that message up. And that's the message was actually retrievable event. So you typically get 3 events per message. Same thing is going to happen in this demo for iOS. Slightly different, but same idea. You're going to have log messages on the top, and you're going to have the events happening on the bottom. You get that second event, and it's receiving that message. Okay. And let's take a look at a more complicated example where we're going to send messages to each other. But before we do that, let's take a look at the Golang example. So for the purposes of the competition, I think this is probably the most important slide for you. I think the most likely thing you're going to do is you're going to run a bot, right? And you're going to send something from your app to the bot, and you want the bot to respond. Easiest path is probably going to be to learn a really basic amount of Golang and do it here inside of the Golang example, inside of the command/root.go file. Around line 205, you will see the message reception loop. So you can look at message content, parse it, right? Say, oh, blah, 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 it did whatever, and then actually send a message in reply. That message send is how you do that is on line 172 right above it. And so you're going to put something like on line 172 on the right-hand side into line 200 or so here, 205 or so, to create any kind of bot you want. And just make this for loop run forever. So get rid of line 186, 187, and you'll run forever. So if you're going to create a bot, that is the shortest path. You can do it in probably about 5 to 10 lines of edits. So let's take a look at the React app running against the Golang app. And what I'm going to do is run the React app, run the Golang app, pull its public key and DM token, and then set that public key and DM token in the React app and send a message to the Golang app. Full screen here. Oh, and this runs in Internet. It doesn't run in Internet Explorer, but it'll run in Safari, Chrome, Brave, and the browser I'm using here is Carbon. It's a Web3 browser. You can see they've linked our xxDK tool on the bottom. So on the top left here, you see that I highlighted the reception keys, and I'm going to the React.js example now. I'm installing the dependencies. I'm going to link the public folder appropriately to the xxDK wasm, and that's just going to link that xxDK wasm folder to xxDK wasm in the public folder. And public is where you put files that get hosted on the local web server. So it's just enabling you to download the wasm blobs. And now I'm going to edit the xxDK.tsx file, the send function. I'm going to modify that token and public key. Instead of using the local one that was generated, I'm going to use the one I copied and pasted from the window above. And just so you can see, it prints it out pretty frequently. All right, so receive DM pub key, receive DM token. Those are the same value. I'm just going to set those values. And because it's JavaScript, you got to use buffer.from and then parse it using base64. And this is Emacs. And I probably should have used Visual Studio Code. I would say that's probably the best editor for this kind of stuff. But whatever you want to use is fine. I tend to use Emacs, but I'm old and I'm stuck in my ways. But I recognize that Visual Studio Code is just as good. It started up a server on 3001. That's what the React app looks like. If you open up the console, that's Command-Option-I. It shows you that it's connecting to all 370 nodes. So it's not connecting to like some kind of intermediate API or anything like that. There's no man in the middle. This is straight up running directly against the XX network. And you can see that it sees the message. So I did not send it emojis because it'd be problematic to display that in the terminal window, I think. All right, and with that, I think we can take some questions. NeoVim is what the old cool kids are using. That is true. So Matt is another member of our team. He is there to answer any questions you might have on the chat. And now's a really good time to ask them. We're getting to the end. So in terms of HackHazards, let's talk about how things are going to happen. Matt and I and Siddhant Sharma will be on the Discord, and you'll notice that I am my Discord name is CryptoMoose, but I renamed myself to Rick at XX. I'm this moose symbol from an old cartoon. We are going to give away 2,500 in XX prizes, XX coins. That's going to be spread out across the top 3 teams. I'm not sure what the division is. And we are also going to give out physical goodie bags to the top teams and the runners-up. And on the right here, you see this QR code. If you have a QR code scanner, I would scan it. If not, I will post it to Discord so that you can scan it later, just the image. And what you're going to want to do is, what is our selection criteria going to look like? Anybody who has a section in their app description that talks about privacy and XX Network is eligible. In particular, we're looking for folks that have where XX Network solves your critical privacy problem. And also if you're proposing to solve it in the right way. As I said during the presentation, we're really geared towards messaging apps. So you're not sending video, you're not sending large images, you're establishing a key or doing something else where the privacy and the metadata around that action is very important. And then I'd like to see some discussion of how much does it help improve the privacy of your app. And what that means is, without it, what are the risks of privacy, and with it, what are the how much does that value? Like, how does the situation change without versus with? After that, I want to see some kind of approach on how you would implement it in a final system. Doesn't have to be how you've actually built it. I understand you're doing a hackathon. You're going to be working on this for a max of a few hours, and you're either going to get it working or you can't, and then you're going to move on. Totally understood. I would really appreciate what you struggled with and get your feedback. And if you ask a really good question on Discord, I'm going to note that and what project you were on. And that's going to go into sort of our internal scoring criteria. Again, Matt, Siddhant, and I are the judges here. And we're going to be, and sort of the final least important thing is, does the implementation work? It is better if your implementation works, for sure. But if you had a really good approach and you just couldn't get it working for one reason or another, it's not the end of the world. So definitely have a section on your submission or in your README of your submission that talks about how you apply privacy to your project. And that is really what we're looking for. And now I'm going to go through and give you like a bunch of architectural diagrams of like how to integrate into your app. I'm just going to jump through these very quickly, and then we're going to do 15, 20 minutes of questions, and then that'll be the end of the presentation. So you could have, some kind of bot running on local to the app that communicates with cMixx and does something with many others. So one of the things that cMixx has is it has a broadcast mechanism built in. So you can have one ID that is listened to by many receivers. So it's one potential architectural decision. You can have, direct messaging and that happening. You can have direct messaging with multiple bots, which also have like particular functions that are outside of the system. This is where you have shared state behind each bot instance, so they're all updating maybe the same database or something like that. You could do some kind of Telegram bot integration. Any kind of integration with any kind of messaging system is a great idea. So I'll just point that out. If you have messaging or the need for some kind of messaging in your app, this kind of integration is a good idea. This is just pointing out you could have a single bot serving a Telegram channel. You could do the same thing for Twitter. Well, this one got botched. So because it has a broadcast mechanism, you can have one person producing content and many clients receiving it. I'm sorry, for whatever reason, this slide did not copy and paste very good. This is just showing that there's 2 different ways to do it. You can also do a push-to-talk app using that mechanism. You can store roughly 720 bytes, 725 bytes or so in each message. When you send messages over the XX network, unlike TCP/IP, it uses a mechanism by which you don't have to wait and see if the other person saw it. It's sort of guaranteed delivery, and that's because the messages last on the network for about 3 weeks. So you can kind of just send it to the address, and assuming you know that it was the right address that you sent it to, you don't have to check that the recipient actually saw it. They will see it eventually. So it's a guaranteed message delivery with some caveats on the word guaranteed, but you could just assume that any message sent will be received if the round succeeded. So essentially, if you get that second update of the 3, I remember I talked about the 3 states, sent and accepted, sent and delivered, and then sent and actually read on the output. So those are the 3 states. If you get to state 2, you can assume that you're successful. Yeah, you could do it with fax machines. You could do it with whistleblowers. You could have some kind of calendar synchronization app. You could do some kind of secret sharing. So secret sharing is the keyword to look up was Shamir, SHAMIR, Shamir secret sharing. You could do Shamir secret sharing by having the user that's doing the secret sharing send messages to each of the people they're trying to secret share with. And this allows you to do that without having any association between the devices, which is really cool. You could do, this is for video games, so you could do some kind of, or not video games, but like board games or some kind of implementation like that. where you share your position on the board with those individuals. You could do some kind of public key registration where you don't want to reveal who's registering, but that the public keys are legitimate. If you look at our, apps that need this are apps like WorldCoin and other KYC apps, where they're doing something that is extremely dangerous. In the case of WorldCoin, they're taking people's eye scans and they're creating a database of, these are that will let you, or an API that lets you check to see if the person behind this private key is a real person or not, right? And because they have all that eye scan data, it's extremely, extremely fraught with all kinds of privacy problems. But if you can store that eye scan data in a way that it can never be decrypted but still checked, and you never have any association between any devices, you can effectively protect privacy in that mechanism. So similar idea if you have a database where it's generated with very sensitive personal information, it definitely plays a role here. And you could use it to establish keys with a VPN for various devices. This potentially you could use xxDK network as a VPN, but it'd be very low latency. So this one I'm less sure about being a great idea, but it's something you can do. This is you could have some kind of betting app where you all submit, and then using the information that everyone posted, you essentially create a random it's not random, but it is a cryptographically secure unpredictable number at the end, and then whoever closest to the guess, or whoever is the result of some algorithm, is the winner of that computation. You could use this to potentially write commitments to a blockchain, and it's really interesting because you can have multiple blockchain servers all listening for these transactions, and then the first one to write it gets the miner extracting value. So that's a very interesting one for this group. You can play poker with it. You can have a bookie use it. You could do multiple bot instances where the bots get some reward if they service the client. You could vote with it. And this is, I believe, trying to show that you could establish Wi-Fi registration with it. Again, not all the ideas are the best idea, but that's kind of what we're going for. So with that, I really thank everyone for your time. Again, I am going to be on Discord, Rick at XX. Please reach out. We'll be very active on the Discord, and I'll be staying up very late to help support you guys, everybody over the weekend. And I'm looking forward to seeing what you all come up with.